Okay, so we are live again. Um, so we have gotten this nice Mandelbrot set viewer going, and and that should be good. So, um, well, for some reason, uh, so not sure why Twitch is doing that. Um, so basically, I should trying to get like these. I'm not like super happy with like the stream quality that's going on right now. So Um, but I don't know if I can fix that without Twitch getting mad at me. So I think we'll just leave it as what it was before. I'm gonna record in a different quality, so hopefully the video on YouTube will become a little better, the archived version. But so okay, let us continue working on this. So we now have panning and zooming. The zooming needs to be fixed. So the zooming is like a little slow right now. And also I don't like the panning. So if you hold, I don't like how it's so jerky. So maybe that doesn't even show up on the stream. I'm not really sure. So I would like to add some smoothing to that. And to do that, um, what I need to do is I think I'm going to change this motion here. So we're going to use a nice, we're going to use some physics to derive the speed for just sliding the screen. We're not going to use like any real values, but what we're going to try is to store let me see here. We're going to have a value we're going to have a couple more values here. So we're going to have an acceleration. Let's call it dd. So the second derivative of velocity of position, ddp. Well, I didn't really mean to use Handmade Hero naming, but let's go ahead and do that. And then we're going to have a v2, which is dp, then, in that case, which will be our velocity. And then our boundary is still fine. So hello, start it Bart fast. um, it is definitely very cool. I'm gonna keep working on it so that it has some more features like auto zooming and stuff like that. Um, so let us continue working on this. So what was I doing? So key down in the key callback. So instead of moving the rectangle directly in the key callback, what we're gonna do is say action repeat we'll just ignore. So if action equals action press, we're gonna set the acceleration. I have no idea what a good value for the acceleration is. But basically what we're gonna do here is if you remember like the equations of motion, basically, what we have is that position over time, position of time is equal to, let's call it capital P, because that's what these variables are named, is going to be equal to P naught, so like our starting position, plus dp times t plus 1 over 2, or 0.5, times ddp times t times t squared. So our velocity needs to be updated at each time step. So right, so if we want an equation here for first of all, like assume this is 0, and then we have a position at time, and if we want, so we can actually say that really bring up the equations of motion so I can remember properly what I should be doing. Yes, so basically I really do not like C++. Besides maybe some very basic features such as, I don't know, operator overloading, etc. But I don't really find those to be super useful. So instead I will use C because I find it to be, well, first of all, it's more readable in general. And second of all, because I don't find that C++ kind of tends to cause programmers to go down like paths of programming things that are not good. You know, abstraction and stuff like that is really the way that C++ does it is not very good. Um, Equations of motion. So I should be looking at these. So, right. So if we want to get the new velocity is just equal to, so v of t is equal to, which maybe we shouldn't even call that dp, is going to be equal to dp 0 plus, or like dp current, I guess, dp plus xa times, so like ddp times delta t, so times dt. That's the new velocity. And then our our position, right, is, so as I have here, it's actually times dt times dt squared is more better. And then for the acceleration, we're just going to set it here. So I don't know what to set this to. We will start with like 1.1, and we will see how that goes. I guess the problem here is that the acceleration actually should be in a specific direction. And yes, so okay, so acceleration does actually need to be a vector because you can have an acceleration in both directions. even if the value that we're going to choose is going to be the same. And the reason for that is so that it can slow down in each direction individually. So we're going to have these two values. And then in the key callback, GDP dot y is going to equal but the acceleration, oh yeah, no, that's correct. That is correct. So this is positive 1.1. Let's set this up here so that I don't do something weird. So float 32 GDP gonna equal to 1.1. We're not gonna care about this delta or this zoom anymore. Or does the zoom, maybe the zoom should influence the acceleration. That is possible. Nothing. It is just a comment. So I am just writing the equations of motion here so that we can, so like right now this scrolling is like very like jerky because I'm like I'm just stepping a position. But instead of stepping a position, I want to have like a smooth scrolling. So yeah, these are just like equations of motion, just to remind me how this works. And also this needs to have some, well, actually it doesn't need to have this because the only line that matters here is this. So if the action is going to be equal to release, then we are going to set this one back to 0. It doesn't really matter too much if I do else if or if there, but and then I'm not going to keep this line around anymore. And these can go up here for now. And then so that is for if we are going up, and then oh right, so sorry. This should be this GDP value. And then possibly this DDP needs to be and also I think we can actually still include this shift. So if this shift is pressed, we'll set the acceleration higher. I have no idea. These are just complete guesses. I will tune them in a second. And possibly we want to still include this zoom, but yeah. I think if we yeah, so we do want to, I think we do want to include this zoom still. If we don't include the zoom, then when we go to we're going to set the acceleration, and when you're like zoomed in like this, it's going to move. That is proportional to the screen size, going to be much higher, and you're going to move a lot further. So we don't really want to do that. So we will try to do it this way. So with that, we can go and fix the rest of these now. So in this, well, let's just copy. Let us just delete all of this. Copy. So if A is pressed, x is going to be like that. And S is pressed. This should be minus. And D is pressed. Well, actually, okay, I was wrong. I think we need to keep the repeat, not for that key, but for the rest of these. Actually, it shouldn't really matter. It shouldn't really matter if you keep the repeat or not. And if D is pressed, it is just X still. So with that, we have a... So then each time we go through the frame down here, we are going to do instead, the rest of this is fine. We have a dt. I should bring those equations with me. Oops. So every time we go through a single frame, we want to update the current position. Either we want to update the, I'm not sure if the order here matters or not, but let's start with doing the velocity first, just for the sake of seeing what goes on. GGL context.dp is going to be equal to, it's actually plus equals. We're going to have to add some sort of drag, but I can do that after. So otherwise, it's just going to keep accelerating to very fast, which will be a little annoying. Oh, and also, actually, also, yeah, without the drag, it's never going to stop. So we do need to include the drag, actually. What would the like the drag is going to be something that's proportional to the speed, the velocity, and it's just going to be an acceleration that is going to be basically opposite to whatever the actual acceleration is. I'm not sure what the drag, what a good thing to do for the drag is. We'll deal with that in a second. Let's type these out first. So this is d dp. Also, these are vectors, so either I write a proper function that does this, or I just do it in line, which I'll do for now. Times dt, and then dy. And then with this new, these are now updated, so we can do, we can calculate a vector delta. That is going to be dot x is equal to, let us save some values here. So x is equal to the boundary, the current boundary. I just need any of either of the values. It doesn't matter because I just need to. Okay, I just want the difference, so I don't actually want the. Right. Yeah, it doesn't. I don't need this. I just need the So I will actually still do the x though. So ddp.x times dt plus 0.5 times this acceleration times dt times dt. And then y will be the same thing. And then, so x equals x, dot y equals y, and then move rectangle, that's going to be GL context dot boundary, going to be equal to move rectangle. We're going to move this rectangle by delta. So we don't really need the delta here. We can just do this. Y equals y. So every time through the frame, we will move this by, we will update the current velocity by the current acceleration. Then we will calculate a new, a position to move to. And then we will move to that position proportional to dt, to ddt, or to dt or whatever. So it'll be like much smoother. And we need to include drag. So drag is going to be a counter. So we will actually calculate a new vec2 acceleration. So A, we'll just call it A. That's going to be, we're going to start by setting it equal to this acceleration. So let's do A dot X and A dot Y. Then down here as well. And we have to adjust it by drag. Okay. Thank you for stopping by. Started Bart fast. Yeah, definitely. And if you want to, all of this code is actually posted on the GitHub. So I'll be update. I try to update it after every stream. So you're welcome to like read through the code or download the code yourself and play around with it. Yeah, have a good evening. Yes, so drag. How does drag, let me remember how drag works. I can't just search drag, that is correct. Equation of drag force or whatever. So it's like a v squared times some coefficient of drag, I guess. And it's always going to operate opposite to the velocity. So a dot x will equal to I have no idea what order I should be defining these in, to be honest. So the order is actually going to influence some things here. So, but we will just see how it plays out, I guess. What can we do? So we have our velocity here, and we're going to take our velocity. Let's actually just save the velocity as well. So v2, I'm lazy. Let us copy the velocity. So I don't have to keep typing this. It's going to be equal to v dot x times v dot x times some coefficient of drag. So let's do F32 AD. And that coefficient is going to be I think I basically just want it to be the same as that. other coefficient I used for the acceleration. That could be wrong. Yeah, maybe that's wrong. Let us just set the coefficient of drag. So, right, yeah, that doesn't seem right. Let us just set it to like 0.9 for now, and we will see how that works. Times kd. So sorry, it should be minus equals for both of these. So it's always opposite to the or sorry, it should be, I think maybe the sign here matters. We will actually just compile this and try. So I've added, I just updated my build script, so I can just do this in the editor now. And it will give us a warning because that function's not being used, but it built fine. So if I close this and reload it, and then if we okay, I forgot a part. So this thing here is always positive. And the acceleration, I think I need to multiply this by the so if the acceleration is negative, we want to if the acceleration is negative, this drag should be positive, and if it is positive, this drag should be negative. So, and then it will just be adding. So either we do this, if we do this minus, and then we take the sign of the acceleration, I think that will do what we want. So a sign of the acceleration, we need to have some new macro here that we will call, I don't know, these can be sorted. I don't really know why, but let's just say they're sorted. We will call this sign of x, and it's very simple. So x is less than 0, then minus 1. Otherwise, it is 1. So if we go back down to our main loop here, and so if the acceleration is positive, the sign is positive, and then this will work out. And if it's negative, this sign is negative, and this will still work out. So that is correct. So we want to do sign of times, oops, my typing is going downhill quickly, times a dot x, sign of a dot x, and a sign of a dot y. And we can build in here now. I should comment that out because we're not using it right now. Though I might want to use it after. So now if this compiles, it won't have any warnings and I won't see anything useless. So that's good. So now if we run this, does the velocity stop? I think it is not stopping. Is it gonna stop? Maybe it's not gonna stop. Oh, and it seems to be, oh, it's speeding up actually. Okay, if it's speeding up, then yeah, definitely I did something wrong. let us do something here. We need to see what is going on with the velocity, and let us just do this. Print, make a new quick function here, just that will just print the velocity and the print motion. So printf so dp is equal to let's do it this way. And DDP, second derivative, is going to be, so first of all, dp.x, dp.y, and then we will print another line, dp, make sure these are lined up. Okay. Then let us say every 30 frames, or yeah, let's do every 30 frames, so twice a second. So if f count mod 30 equals 0, print motion. Oops. F count mod 30. Okay, there we go. So we're going to do this. We start. So okay, I think maybe the drag is just too low. Doesn't seem to be speeding up, actually. It is going down, just like very slowly. I think maybe we just need to increase the drag. Nope. Nope. It is that is causing it to speed up. So even though, yeah, the acceleration is 0. So this is not correct, obviously. Oh, because if really, I think this should actually be the sign of the velocity, not the sign of the acceleration. Oops, I didn't rebuild. Okay. Does seem to be slowing down over time, but I don't think it is fast enough. I think this just needs to be like really big, because the velocity is very small. Physical equations of motion. Yeah, that is more better. Does it actually stop though? So I think it's still moving, right? Um, oh, and I also should have checked these. Okay, maybe I need to not. I don't know how to have the chat. The chat doesn't want to load on the stream properly, so I should get rid of that. Um, I'll just hide that for now. Leave that as that. Yeah, that's unfortunate. I need to. I should. Well, I think this might move though every time I do something. No, it doesn't. Okay, that's fine. So we can do that. Um, so there we go. So something like that should be okay. No, I still don't quite like how I'm doing this, but that's fine. Um, so let us see. We also just need to basically threshold this. So if the velocity is less than a certain uh, see, because these are not like modeled after anything real, these constants are kind of like arbitrary, which is like a bit of a problem. Um, the acceleration is not high enough. That's for sure. Um, Oops, not that high. I need to rebuild that. Wait, how did that cause DP to become NAN? What part of that is causing it to become NAN? That is a good question. Is it like a problem with the zoom? Thought I tried. Thought I had this at 20 and it didn't work so well. Ooh. Wait, it should be like initialized to 0, so why is that happening? Um, huh? What? I'm very confused. I have no idea why that happens. Um, because why does it just go to like infinity? There's no division going on. Like dt here is like fixed, right? So, um, uh, very weird. Very, very weird. What are the equations of motion that include drag? Because I think I'm doing this maybe wrong. Like, is it because the like this is fine? We just get like a constant uh like that's too heavy now. But wow, amazing. So what why is that happening? I don't know. Let us just these values are like not good. Let's just comment this for now. Even though that is not being set to anything. Actually, yeah, that doesn't matter because it's just zero. Yeah, yeah, yeah. Yeah, yeah, yeah. This is fine. Um, why is that doing that? What happened? When we're resetting, we also need to basically um, reset those velocities to 0 as well. But um, so where is that mouse callback? I have no idea why the um, everything is going to 0. Let us do this. Um, What is happening that is causing that to just do that? Time to read up on IEEE. How's it going, you in 64? Um, I'm just doing some multiplication here. I'm not even doing any division. It shouldn't just do that. Um, well, let us. This drag is probably too high. Um, like I am noticing that we're getting like -0 versus +0 in the motion. So I don't know if that has something to do with it. Like we're still drifting. It's weird. I mean, this is what I was kind of expecting to happen as we did this, but actually, it feels pretty nice when you are like at this zoom. Also, like as you can see, the velocity here is reported as 0, but we're still moving. So, um, I guess it's not exactly 0. We do want to like. So when the acceleration is just 0 and the velocity is less than some threshold, we should just like clamp it to 0 maybe, I don't know. Um this is like getting printed like way too often as well. I don't need it to be printed that often. Um it's like the drag force coefficient of drag. That's not like how that applies. Oh, well, like apparently the coefficient of drag. Oh, no, 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 no. No, 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 no. This equation all looks like basically what I've got here. Um, I can see it, we're still like scrolling just like very slowly. Um, definitely if the velocity gets below like some epsilon, we need to just clamp it to 0. Um, if um, let's just make this a little easier on ourselves. So v2 new v is gonna equal v dot x minus um, plus a dot x times dt, and then be specific here, and dot y is equal to v dot y plus a dot x times dt, not a dot x, a dot y times dt. So new v, if new v dot x less than 0. I will move this up to top 0.0000. I don't know, 0.001 maybe. F for new or okay. Really, I want the magnitude, but that's fine for now. If new v dot y is less than epsilon, new v dot y is equal to 0. Then we will do this equal to new v. Let's close this and retry this and see how this one works. It'd be cool if it didn't just go to infinity. Well, it doesn't seem to go to infinity anymore. I don't have any idea what I switched to do that. It's possible that because the numbers were getting so small, it was doing that. Oh, you know what? That's because the velocity is never getting updated because yeah, that's actually a problem because so if a dot x times dt is less than epsilon, then v will never even get set. So epsilon needs to be like particularly small. Just any small value should be fine. So now maybe the drag is too high. Oops. I also don't quite understand why it's faster in that direction. Well, yeah. I actually do understand why it's faster in that direction because this needs to be a magnitude. So I will just define a function for this so that I don't have to keep typing it. Magnitude v2 takes a v2v and returns v dot x times v dot x plus v time dot y times v dot y. So that now it doesn't care about which direction you're looking. And then we can also set this higher again, like, I don't know, 50 or something. Going 100% by feel here. If magnitude v2 new v less than epsilon, the new v is going to be equal to v2 of 0. doesn't stop like fast enough. I still don't like how slow it stops. Um, that just means we might need to make the acceleration higher. Yeah, so need to fix the zooming as well because the zooming is really annoying right now. As you like zoom in, the scrolling is like nice. Like, I like this. Oh, it doesn't stop fast enough. Why is it still moving when it's been clamped to 0? Okay, maybe the epsilon's too like small now. Um, See, the acceleration was supposed to be proportional to the size. Now, like when you zoom in, it's when you zoom in that it's lower, but it still looks like. So maybe it needs to be like. Not sure. Key callback. Okay. Well, still wants to go to Nan for some reason, and that is very not nice. Wait, why did? Um, yeah. So first of all, this key callback, it does need to be repeated because if you like start moving in one direction and then start moving in the other direction, before you release the other key, it just gets set to 0, which is not feeling so good. So glfw repeat. Um, divided equals 1. Oops. That was silly. Um, why did I do that? Okay. Didn't need to build it here. We'll do this. It seems really weird. For some reason, it seems like when the zoom is 1, it sometimes decides to go to infinity. That's the only place where I'm dividing is by 1, and the zoom. I don't think there's any way that the zoom is ever going. I mean, like if we're worried about it, we can just do zoom. Uh, zoom is greater than 1. Um, then we use the zoom, or we just use 1. If for whatever reason it's deciding that the zoom, I don't know. I have no idea about the zoom. Like it's like a little hard to position once you get small like this. So um which is weird because the zoom now is like quite high, so like the acceleration that we're just setting shouldn't be so. Maybe we need to like make this let's do the calculation here. So scale equals zoom times zoom. It's like make it a squared value, so it's like even more um rapidly declining. And then scale equals if scale greater than, if scale is less than, scale should like never be less than 1. I don't see how it was becoming less than 1, but that's the only thing that makes sense for this blowing up somehow. Um, so it's like right at the start of the program, we set it equal to 1 before we even do anything. And we can just, before we do anything at all, we can just set zoom equal to 1 and boundary equal to boundary. But it shouldn't matter. Um, oops. So 1, 1, 1. This should have been scale. Oops. I don't know why like, how does that happen? Yeah, so like now that like the zoom squared isn't good either because now that doesn't, now that scrolls like, now it's like impossible to scroll. Who knew that doing some smooth math could be so annoying? Um, it needs to be scaled because if it doesn't get scaled, then bad things happen. But let's just see if the scale is contributing to the going to nan part. No. Oh, I didn't actually rebuild this, did I? Probably not. Um, seems to be when I'm like switching the keys like really fast that happens. Yeah. That's not nice. That is gross. Um, why does that happen, dude? Like, what is going on with that? So this is our new delta now. Um, maybe it's like more readable if I just do. But that is not the problem. Hello, Chandu. Um, I am trying to find out why. Well, let us just go back to here and reset this scale. But the scale is like too much, so zoom greater than 1. Zoom otherwise 1. Um, well, I don't know if my ways are too helpful because this is not working how it's supposed to. Sometimes it just, for some reason, the velocity is just going to nan, even though. So if we scroll in, yes, the window is all being drawn in OpenGL, but um, the issue with the velocity um, is not related to OpenGL. Let's get rid of this print motion call because it's just annoying me right now. Um, so no printing motion right now. The drag is supposed to apply a force um, opposite to the other force. So we're not caring about mass. Um, so which part is looking complicated, and maybe I can explain it. um, like the drawing itself, or the code. Um, I have no idea because I do not. I am a graduate student, so I do not have a real job per se. Maybe. Um, I'm mostly just doing this for, well, learning purposes and fun, but wait, whoa, 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 whoa. Why? Wh- Huh? Why is it like, um, well, I do actually know why that's happening. Yeah. I do need to normalize that actually. So part of the issue is I need to normalize that. Um, so where was this magnitude function? I should move this up to here. Um, so we've got we got a magnitude, and then we also need a um, V30 V2 um, normalize V2. And we're going to calculate a magnitude. Scale is equal to magnitude v2 of the vector. Oops. And then v dot x divide equals scale. V dot y divides equals by scale, and then we'll return v. So we do need to normalize that. So because right now, if you have motion in both directions, you kind of get like twice the acceleration that you should be normally getting because it's not normalized. So what we're going to do is in the key callback, instead of doing this, we are going to do v2 ddp, and we're not going to have this part anymore. This is going to be used for scaling at the end before we just return or set the magnitude. And then in these functions, we will do dd, this should equal 0 to start with for 1. In these functions, we will set ddp.y, ddp.y, oops. That all looks good. And then here, we are going to do some thing with the scale. And then this is going to be scale divide equals. And then dp dot x times, sorry, so ddp dot, what's it called? So ddp equals normalize v2 ddp, and then ddp dot x times equals scale, and ddp dot y times equals scale, and then we will set vg, we will set the global ddp to this ddp. And I did something dumb, clearly. Yes. Um, oops, and I also I did a couple dumb. So this should be 1, -1, -1, 1. And then here, like this. Oops, and then I broke something down here. Okay, so let us try this again. Well, wait, whoa. I don't know why that was black. Well, we're still having that problem, but oops. What is happening there? So, um, well, now that we're normalizing, well, I think am I normalizing correctly? Yes. Well, maybe I'm doing something really dumb. So what I can do is, um, uh, I will use Clang's very useful undefined behavior um, sanitizer, and we will see how that one goes. So let's just add that. Didn't really need to close that. Now if we do this, if we start seeing weird undefined behavior warnings, we're not. Huh. Well, so that was worth a shot, but that is not seeming to be the problem. I wonder if it's like in the shader, it's getting like messed up. Why could it be getting messed up in the shader? So we are sending the boundaries, and then the boundary is getting I don't think there's anything in here that could be causing that right now because the yeah, I don't think the shader is the issue. So what about um hmm, let us try to use Let me just lower these values and then also lower the drag and just see if this issue still shows up. Um, is this the new velocity? Old velocity plus acceleration times delta t. Yes. Yeah, that's correct. Um, that is interesting. So now it seems to be when I'm letting go of the key that is happening. Um, oh right, so this is actually not quite correct. We need to take we need to use this. I think like see it shouldn't be an issue, but um technically what I'm doing is just having a I build that. I'm just having like an instantaneous. That shouldn't be happening though. So when I like let go of the key, when I do the key release, uh, so what is happening with this? I like to just leave this open. um, why does this not like what is going on here that's causing this to just instantaneously jump like that sometimes? Oh, that all looks good to me. How about in so these equations of motion are doing some weird thing. I don't know why. Our acceleration dot x. We want to apply some drag to that. So we're going to take the sine of the velocity and then times that by the square of each velocity. Times our drag coefficient. This looks good. So it should be the drag should always be proportional to the velocity squared. That's how the drag is supposed to work. Um, Magnitude is small. We need to set that to 0. And then if that is 0, oh, right. So here there's a problem. Okay, this part of the equation is wrong, so this shouldn't even be here. We basically just move, we don't need to account for that actually at all. So we can just use the acceleration to update the velocity and then use the new velocity to find the time step. Really, I think it should be the old velocity for this delta part. So before we go and update the before we go and do the math to update the velocity, we will just do that first. No, there is not uint64. So one of the goals with this is to not do crazy window management, because that's kind of something that your window manager should be doing. But under but because like the original author wanted stuff like this status window and like the message window, like this message window, he added this splitting functionality, which is kind of against that sort of no doing window management concept, but that's sort of just how it is. Yeah, so long story short, right now you cannot do both a vertical and a horizontal split at the same time. Okay, so how do we do it? How is it? Why? Why? Why does it do that? Why does it just instantaneously jump like that? Is it like a problem with this calculation somehow? Yeah, so like the long-term goal is to not do window management at all in this and to just entirely leave the window management manager up to doing that. However, understandably, the right now the support's like a little weird. um, there's like this weird sort of half supported case, which is kind of, yeah, I can see why it would confuse some people. Um, what is going on here? Like, is it because this sine function is like here's sine. Um, shouldn't matter though if you do less than equal to 0 or 0. Like it shouldn't matter either way. Do I need to step through the program? That is possible. Um, if we turn off optimization, is this still going to be an issue? Because if it's not, that's annoying. Okay, it is, so that's good. So, um, oops. I want to set a break at uh, key callback. Probably should do this first because yeah, it is not. So, okay. Break key callback. Um, what am I typing? So, um, probably I should. Um, why did that not register? Okay. The problem is that this is like a thread, I think. So this might be in a different thread. I'm not 100% sure about that. Oops, I shouldn't have. Well, I shouldn't have been stepping through those. That's fine. So let's display. Uh, and display this one as well. Oops. So the boundary there is looking fine. And display A. The velocity is currently 0, so that part is 0. Somehow the velocity just jumped to this. the math makes sense for that velocity to just jump to that. So the acceleration is 10. dt is 59. Why is dt 59? dt should be in milliseconds, right? Why would dt be or in sec? Oh, right. Yeah. Oops. Right, since we're in the debugger, um yeah, this is not going to be so easy to do. So dt is going to be like really large in the debugger. Okay. Well, I don't know if the debugger is going to help me with that then, to be honest. Um, okay, so how can I fix this then? I don't want to go back to the stepping because I actually like the smooth scrolling. It's just it needs to taper off appropriately every frame, and somehow that needs to be proportional to. So delta x, like this all looks fine. Um, I don't quite get why this is happening. Um, like I don't think there should be like any undefined behavior going on here because it's just some basic math, right? um, this is the new velocity. This is the old velocity. Maybe the drag is just like way too massive. Then we have to figure out how to scale the other acceleration appropriately. Um, Maybe I need to use the drag a little differently. So instead of just having this instantaneous instead of just having like these instantaneous jumps in acceleration, which are not physical, we need to comment these out. Then the acceleration needs to get updated every time through the loop as well, which means that if the acceleration needs to get updated, that's no good. So I don't think this is the problem though, because we have our acceleration. It does not equally apply to. So this part is technically correct. Then we update our velocity and we I mean, I don't know. So this delta, like, um, stuff needs to still be here first, and then we need to do the update of the. Maybe we should go back to this thing, and we will do this every 2 seconds, maybe. Well, I don't know how useful this is though, but right. Commented that out. Wait. So I'm just pressing a completely unrelated key right now. Just any key press is causing that to happen. Okay, so now maybe we know what's going on here. Maybe I can figure out now. Any key press. Why would that be happening? Oh, what am I doing? Key callback function. Okay. Well, yeah, this shouldn't be commented either. That was a dumb idea. Um, Let me think. So this is all like fine. None of this should be causing an issue. Anytime we go through here, we should be normalizing, and then wait, it's like this normalized thing. That is the problem. This normalize is not good. Yeah. This normalize is not good because we're now dividing by 0. That is the problem here. I'm just gonna go to the wash. Um, okay, so the problem is this normalized equation. So we need to only be normalizing if magnitude is greater than 0. If magnitude of GDP greater than 0, then we should normalize and do all this. Otherwise, and set the and update. If it is just 0, then we shouldn't be doing nothing. That all of this goes in here. So if we build this, now I can press stop without it just doing weird. Okay, so at least it's not. The acceleration, why is the acceleration still? Why did the acceleration never go to 0? I let go of the key. You don't want to you don't want this to go to 0 every time the. Oh, right, so. Oh, no, that's not right. So now if we come through here with any other key pressed, this is still going to get normalized, which is not correct. Actually, oh yeah, it doesn't matter if you, yeah, that doesn't matter. What matters, what does matter though, is that this needs to get set to 0 somehow, and it's not getting set to 0, and that could be because. Right. So if one of them is. So if one of them is already 0, and then you set the other one to 0, this never like gets updated. So I think that I need to just not be. I think we need to just do. Um, this still seems wrong because you don't want to normalize. So the value you want, you don't. The one should be getting set and the other one should be going to 0. And if they're both set, then they need to be normalized. Yeah. So if they are both set, they need to be normalized. If they're not both set, they don't need to be normalized. So let me just redo this thing. So this thing is needed up here. F32 DDP, this is what I used to have. And this was going to be, there really was just this scale. And then in here, the new one is the scale. I shouldn't call this scale because that's a dumb name. The new one will be this. So if the magnitude of this is greater than 0, and what? And now what's going on here? Okay. And absolute value of the delta between these two things does that part matter? So only when they're both set do we need to make sure it's normalized. Yeah. So yeah, that's right. This is correct. So if the absolute value of this thing is less than epsilon, which is not in the right place, so put our funny epsilon constant not there, but up here. Key callback. So if the absolute value of the epsilon, okay, then we need to normalize this. Wait, that doesn't make sense. So when we just go to normalize this, we are gonna make the magnitude of it 1, but we want to make the magnitude of it equal to scale. Does this make the magnitude of it scale equal to scale? So if you multiply a vector by, if you multiply a vector of magnitude 1, I think it should be like the square root of scale to make its magnitude 1. Yeah. Yeah, that's right. The scale should equal I don't have math included, and I don't really want to include it, but I guess we will have to for now. Replace with intrinsic. Wait. Duh. Well, this normalized was already incorrect because it was supposed to be that the square root of this magnitude is the scale. Um, that should be square root f. Oops, I didn't need to do that. So what happened here? Oh yeah, so now because I have this stupid. Oh no, because this should be ABS. I mean, technically there's some. Yeah, there's some nonsense in. There's a few problems here. First, we need this to be here and here and here and here, and that doesn't need to be there. And then we need to do 153. And that should be there. Oops. What is the problem here? Oh, nothing. This just didn't close. Okay. Yeah. Okay, so now we're finally back to something that's not completely broken. Um, no print motion, because that is like a little annoying. And then AD can get re-increased. Okay, so now we should have something. KKD needs to be higher, and acceleration needs to be higher as well. So now we will go back to seeing if we're gonna hit this annoying problem from before. Now that I've fixed some of these bugs. Yes, we are. It does not like the big acceleration for some reason. Why does that like is it because I should be using like the equation for like momentum instead? So we should be increasing its momentum and not using drag like this? Or is that the same thing? I mean, I think momentum and drag are like the same thing, right? So momentum is mass times velocity. Um, yeah, I don't think that's correct. I don't think I care about that. Why does it go so crazy when you press shift? I don't get it. Like why can you not have such a high acceleration? Oops, there's like nothing here that I don't know why the high acceleration causes an issue, but we will just leave this at 20. And shut up this warning that's about to happen, and go here and turn this down again. Close this, open it. Because it gets like to also the normalization is not doing what it's supposed to. I think epsilon is too high, but and like the scale quickly becomes a problem. So I think that I need to do something different here. So first of all, this epsilon is too high. Second of all, this um, Did I make a clamp macro? I didn't. Let's make a clamp macro. Oops. Or x is greater than or equal to high. I or x. T um I don't want to do that. I don't want this part here. I just want to use this like clamp this to actually really what I don't want this. I want if um so first of all zoom is not so it's anyways if zoom is less than if zoom is greater than a certain value, we're just gonna clamp it to a lower value. And if that value is gonna be, I don't know, like the drag, um, let's try like 100. We'll just clamp it to 100. Or this. Okay. We need to have some way of huh. I don't like this. I don't like the scrolling. I don't know how to get it to go good. How can I get the scrolling to go nicely? That is a good question. Um, we want scrolling to go nicely, and I don't like the scrolling right now. There's all these like move towards, but I don't want to use like do that because it's annoying. What if, why am I like so off center? What if instead okay, so first of all, this thing needs to be proportional to the zoom in a different way than it is right now. So first of all, zoom as zoom goes up, this needs to go down, but it should probably be more than just the zoom. It should maybe be proportional to the boundary size. Um, so boundary aspect ratio will be constant, but the boundary size is going to go down. If we want, let us do a little bit of an equation here called sub v2, v2a, v2b. It's going to return v2 dot x equals b dot x minus a dot. Probably this direction. So this is going to tell us the this is going to tell us the yeah, this is going to give us the diagonal vector of the one corner to the other corner. And maybe we use the magnitude of that as the acceleration. And just try that. So instead of setting the acceleration like this, we do like all of this can just go, let's do equal to magnitude v2 of sub v2 GL context dot boundary dot top left and boundary dot bottom right. That's going to give us a value. Then I think these should still be this one thing. If the magnitude of this vector is greater than 0, then we want to actually, never mind. This is good. We want to normalize it, and then we want to multiply by the scale. So and then we need to add like a multiplier, so that's because that's like too low. Um, that's weird that it's not like more proportional to that. Um, does the do that? Does the multiplier need to have some sort of relationship to the zoom? Because it is like too fast, right? We don't want it to go this fast. It's really annoying when it goes like this fast. Uh, okay. Um, we need to times equal this by 100 divided by the zoom. I don't know. Problem is like the zoom, this acceleration becomes like a problem for high zoom. Also, this might be too fast, but that's proportional to the magnitude squared. Um, the magnitude should be small here, right? Or like these bounds not correct? Is that like what the problem is? Wait for this update. So yeah, right, okay. That's the problem. That is why that's happening, because the bounds are not, I forgot, the bounds don't actually take account of the zoom right now. That is the problem. The shader is using the zoom to adjust the boundaries after the fact, which is uh yeah, basically not what we want. So I'm going to delete that part of the equation. Um, so the zoom is no more, so need to fix that in the main as well. U zoom is no more. No more U zoom. And then here we want to scale the we want the rectangle that we're so right now we're using like a delta thing, but um yeah, and actually we want the delta. Delta is good. Um should the delta be proportional to the zoom? Maybe that's what needs to happen here. Like the delta will just add as like a constant scaling. And then but we need like the rectangle boundaries that we're just sending to be scaled down first. So if the that's not true. We need the rectangle boundary to be normalized. Um, so like it needs to be right. So the delta is not proportional to the zoom, but the width is. So when we adjust the zoom, which I'm using in a ton of random places, um, I'm not actually using the zoom in that many places, right? So we're just resetting everything and printing it. Okay, so I don't even know if we need to save the zoom, to be honest. Delete this. Scale this up a little bit. Scroll callback. So when we zoom, we want to scale down the edge length of each of the rectangle's borders. So um, so v2 delta equals GL. Where did we? I'm gonna copy this from. Is it here? Just want to copy this. Oops. Okay, so this one. So we have delta x and delta y now. And really we need the magnitude of those, but we are gonna take those deltas and we are going to calculate a value that should be decreased by based on the zoom factor here. Um, right. Move this around. Um, so, oops, what happened there? We want to decrease the magnitude of these two things related to the zoom. How much by the magnitude? So, maybe it should be um like a tenth, and then it's like maybe 0.1. If this is just pressed, um, it will be, that might be too much. A tenth might be too much. So like 0.2 if it's pressed, 0. By like a fifth, and then if it's not pressed, it'll be uh like a 20th maybe. Um, so that's our scale. Um, then delta dot x times equals scale. Delta dot y times equals scale. Then we want to and also it should be times by half. Um, yeah, times by 0.5. And we want to increase the so we're going to use this actually. So for the new bottom right is going to equal the old bottom right minus the delta, and the new top left is going to equal also these values need to be like absolute. So um, add that and delta. Okay, so we're gonna shift that, and then we're gonna not care about zoom anymore, I don't think, because that does not seem useful. That is no more, but okay, so something like this maybe, whereas the bound's gonna be like hidden. Bound is gonna be hidden, unless I leave it on a different line, so that's fine. Okay. And then dt, no more zoom. And then this all looks good to me. Make that a little bit more readable. Okay. Now, sub v2, we are going to have add v2. Okay. Now we can close this and write this thing and do a Mandelbrot. Okay. That's not quite what I was picturing happening, to be honest. Why is that getting compressed in that direction only? Also, why is... there's a mistake going on there. um, the boundary needs to be shrinking. Why am I not in the scroll callback? Oh, right. So if we need to use the sign of the delta y here. So also we should be multiplying by delta y. This isn't quite right because it's not actually this is like decreasing and increasing the bounds. But not how we want them. Uh, Interesting text I'm getting. So this is not what we want. um, so it does do like what I'm telling it to do, but also I need to flip this because it looks, this is not what I'm expecting it to do. Actually, hello, Mr. Mugame. Mandelbrot is going good, but I need to figure out the correct way to zoom in. Um, if we decrease the boundary, and then this is what gets sent to the GPU, the top left and the top right, and the screen dimension. We need V to be, we need this that Mandelbrot function. It's a little weird right now. So what do we got going on here? We have got that this scale in each direction um okay, so the scale, what is this scale? Like this is meant to map this V into the correct space. So it needs, this looks like, well, it is obviously correct because that is like working. Um, but why does this not? I guess the difference before was that this, we scaled each of these dimensions individually, and now I am scaling them. I'm still scaling them individually. Uh, this is literally the same equation. This V needs to be inside the boundaries of that. So if we've got pixel space and then we convert V to screen space, or sorry, from 0.0 to 1 in both directions, and then we have this Mandelbrot, the magnitude of the Mandelbrot screen thing in each direction. This should like technically work. Doesn't work. So how do we fix that? Why does it seem like, why is it zooming more in Y? We need to maintain the aspect ratio when we're scrolling, when we're shrinking the dimensions. In that case, no, that's what's going on here though. Oh, no, it's not. Duh. I don't think I can use these functions for what I want to do here. Yeah, no, we can't do this. It's more effort to use those functions than to just do the math here. So the top left dot x, that one is gonna scroll in. So plus equals delta dot x. Top left dot y needs to be subtracted. then bottom right dot x needs to be subtracted, but bottom left dot y needs to be increased. Yeah, and we're not using that function anymore. That's fine. I'll delete that in a second. Okay, that's more like it. Um, the yeah, so we do want the um ooh. Oops. So those equations of motion I'm still not happy with. Will I ever be happy with them? Who knows? Move somewhere interesting. Why is that like let's get rid of this add v2 function. I don't need it. What's going on here? Doesn't matter. So first of all, key callback. Yeah, so this thing is correct now. Without the zoom being passed in, which is good. We didn't really need that. In the key callback here, this acceleration, we're trying to make it proportional to this distance squared, the screen size squared, like the diagonal distance squared. But that doesn't feel quite right. Also, it should probably be like, probably shouldn't be that magnitude. It should probably be the delta x and delta y individually. Dot x times equals 10 dot y. But this 10 isn't quite good. Maybe it just literally, okay, so we deleted that zoom parameter, but maybe I should have keep track of that and do this. Maybe I got rid of that too quick. The zoom here should be like the inverse of this scale. So And then also we still need to clamp the zoom. Oh, and also this is only ever going to grow. So times this sine of y delta. Or I guess, okay, well, y delta, just times by y delta. Y delta is always 1 or minus 1. And then we still need to clamp this. So if GL dot zoom is less than 1, we just set it back to 1. What happened here? Okay. And we are not going to well, we do want to normalize this. But what's the scale here coming from? Right. Yeah. We want the magnitude of this vector. But no, that's not right. We want to normalize. We're going to use the zoom as the scale, and then we're going to normalize this. And then we're still going to use this zoom as the scale. And then down here, we're kind of doing some work we shouldn't be doing, but that's okay. Down here, we will just set this equal to dp. Okay, so let's see how this comes out. So we can zoom in still, but that is not right. Right. Yeah, we don't want to normalize this. That's bad. Because I can grow it. If it's like small value, it can grow. Nope, 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 nope. I am a little suspicious about this still. So this is all not here anymore. We want our DDP to be doing what here? So shouldn't can't be normalized. Cannot be normalized because that is the problem. If the magnitude of this is greater than 0, which means we need to adjust the thing. That's always going to set it to this value though. If maybe we'll just get rid of this concept for now. Just try this. And wait, what? Oh, that is not good. That is not working how it should be working. Float precision issue. That will have to be adjusted later. I think I flipped one of these signs. No. Okay. Oh yeah, this yeah. I did. Um what can I do here? Times equals 10 is like not good, but this is also not good. Yeah. So x needs to be flipped because x needs to be flipped. Um doesn't stop fast enough. That's part of the problem. And then yeah, just like um that's part of the problem. It needs to stop faster. I don't know about this drag coefficient. It seems not good. Um, Yeah, I need to look. I think I need to look at the equations of motion again and find a better way of doing this. Because I'm not happy with this outcome. Let me check how much stuff I have just changed here. So this equation, I am happy with the zooming part. I don't know, it's just this key part that I'm not happy with. Well, the zooming part still has some work, obviously, but because I'd like it to zoom, I'd like it to move, keep like the mouse at the center, but um, what part of this is bad? So this, we used to do this, and this delta was what? Weird. It would still diminish with the zoom going up. Um, yeah. So I do prefer the smooth scrolling to the not smooth scrolling, but like it's not really fast enough. That's like part of the problem. Also, this doesn't like stop when it. Yeah, it's like really janky. Um, so we need some concept of like momentum, and not related to drag. Um, and how does the momentum play into the other parts, I guess. I think I need to review like some equations to figure that part out. Um, well, so I think what I will do for now is remove the smooth scrolling, I think, and just go back to this part. Um, go back to this, and I'll try to do the smooth scrolling after. It's just that well, maybe we can still do the smooth scrolling. It's just without the acceleration. Let's try that first. Let's use the. We'll still use the velocity. We'll use velocity, but not acceleration. Let's actually just make this velocity, and this velocity will be proportional to the distance, and then um, in here. fine. And then in the main equations, we will get rid of this whole thing and this whole thing. No. Yeah, this part. Comment that out. And we're not going to be adjusting the velocity. And we'll just try this. Oops. So V is this. Forgot about the warning. Then, hello Nick Blue. Yeah, that velocity is like way too high, but it is smooth scrolling. So let us fix the velocity. I don't know if looking at the Mandelbrot, we are seeing a Mandelbrot here, so I'm kind of winning. But my physics are not too hot right now. But that's okay. So key callback. Where are we here? Let us get rid of this multiplier by 10 for now. Try this. Okay, so this is like all these. Oh yeah, even I don't know why that. Okay, I do know why that's getting stuck actually. Okay, so this is like better. And actually it's too fast, so probably a little bit less. Probably like a 0.5 multiplier is probably good. Better. So I can explain some things if you have like specific questions. Mostly there's nothing like too, so that that scrolling is okay. And I kind of want to actually reuse this shift so to calculate that multiplier. So if mod and what key is this called again? Where are we using this? That's not right. Okay. The key called key callback. DLF mod shift. That's what it's called. So if this and mod shift, then the scale is 1. Otherwise, it is 0.5. So I can. So this is something called the Mandelbrot set. You can look it up on Wikipedia, but it's actually very yeah. So this is like the Mandelbrot set. The Mandelbrot set's this very strange little equation um, where um, yeah, so it's generated from, it's called the Mandelbrot. So the Mandelbrot set basically, let us open an empty window here. So if, yeah, I'm not really sure how the guy who came up with it, but basically, if we have some equation here that's defined recursively, so z, so new z, let's call it z prime is equal to z, um, in this case, it's z squared plus a constant. So basically, if z here is a complex number, so really it's just z is actually just equal to like this little duplicate number here, this, and if so if after we iterate through, we do this, we calculate this value, we keep incrementing it up and up and up for a number of tries. So in my case, we're trying 300 times. And the magnitude of it is less than 10, though this doesn't really matter too much. Then we assume that it is in the Mandelbrot set. And then if it's in the Mandelbrot set, we color it black, so it doesn't get any color. But if it's not in the Mandelbrot set, so we figured out after calculating this over and over again, some number of times less than 300, or its magnitude went like way out, its magnitude like exploded. We assume that it's not in the Mandelbrot set, and we assign a color to it. And that color, which is what all these colors are, is just based on like the number of tries it took to figure out that it wasn't in the Mandelbrot set. So a lower number of tries will get colored closer to blue, and then a higher number of tries will get colored closer to red. That's why like near the boundaries where we don't really know if it's in the Mandelbrot set, it starts being like red, because it could possibly be, if we just tried a few more times, maybe it turns out it was in the Mandelbrot set. Or sorry, I mean that we took like many tries to figure it out. And yeah, and then we just color it based on that, based on like how many tries it took. We assign like some color to it. And yeah, for some strange reason, if this z value is complex, which it is, you get these very strange patterns everywhere. It's very hard for me to just like, I don't really understand why. I don't think even the person who came up with it understands like why you just get these strange patterns everywhere. But you do, so that's pretty cool. And the other thing is like these patterns, obviously none of them are the same, right? Like you scroll around here and there's like some that look like they might be similar, but they're actually like they're not. All of them are different. They're all very weird and different. So yeah, now now that I have this zooming and panning implemented, well, it's mostly just programming and looking at interesting fractals, but yeah, so I don't know. It's totally up to you. Thanks for stopping by if you are gonna leave. Um, there's like yeah. This is just like for fun. There's no no logic or reason to this. Um, yeah, it's just basically so I can learn a little bit more about graphics programming and have some fun. um, yeah. So but basically here, what's happening is, yep, exactly. I'm just using C and like GL shader language. So most of like how these colors are being selected is actually in like GL, like the shader language. Um, but like the things like shifting and moving around is all in like C. I'm not sure if it's like that weird. So a lot of people use like C++, I guess, but also a lot of people just use C. So um, yeah, so why this is occurring is because we don't have like enough iterations. And if I increase this, it's going to slow down, but basically it should become, well, it's also, there's two issues here. So yeah, actually it's not really this issue. And also I don't think it's this issue either. Yeah. Um, no, like, like video games and stuff are all written in like C, C++, mostly C++, but C or C++. Um, like some games are written in other languages, but for the most part, like all the high performance games are written in C and C++. So what is happening here is basically we are running out of precision for floats. So everything here is calculating using floats, but um, they are not precise enough. What happened here? Why did this freeze? I don't know. Weird. Yeah, if we zoom like way in anywhere here, it's gonna be the same thing. We eventually get to this point where the pixels, so where we can't be like, uh, yeah, where basically, um, how do I describe this? Um, so there's basically a, yeah, so exactly. So floats, so like one thing to fix this is you could switch this to double, but then you'd keep zooming in and you still run into this problem. So what I want to do, I also don't know why it's getting locked when I do that. When I zoom in so far, it just gets like locked in place. That's really weird. Anyways, what you can do instead, and what I'm going to try to do, probably, I don't know about this time, but at some point, is chaining bytes together. So basically, what you want to do is it's called, I want to have like, I need to do like part of the calculation in float and part of the calculation in int. So I use the int for like the large part, the large numbers, and then I use floats just for calculating like the delta. So the small deltas around like the large zoom value will be calculated using floats, and then the main part will still be calculated using ints. And so to do that, um, there's like a few things I'll have to do. Um, how will I do that? Might have to like do some research actually to figure this out because I haven't actually done anything with like that sort of um it's kind of like fixed point. It's like a combination of fixed point and float. Um oh no, I'm calculating this every frame. And actually I'm limiting the frame rate right now so that it doesn't completely bog down my computer. This can like be calculated like thousands of times a second. Yeah, yeah. Like right now, it's being calculated every frame. I just have like VSync enabled, so it only does it 60 times a second. Um, well, it's not. So it's not a solution. It's not a good solution right now where we're just looking at it. But long term, I want to like animate this, so it will automatically zoom in and have to be updated every frame, anyways. So we want to make sure it's like fast enough that it can do that once it's ready for that functionality. Hello, Blistered X. Um, yes, there's a delta time. Right now it's just six. Like I'm not sure what you mean. I guess. Obviously, it's going pretty good. We got some cool Mandelbrot being drawn on the screen, so that's always fun. Um, yeah, obviously there's like a delta time. It's just right now because we are just in limit it to 24 and go from there. No way. Why would I limit it to 24 if I can draw it at like 60 or even faster? Nice and smooth. We want smooth here, not slow 24 FPS. GLSL is pretty, it's actually like really simple for processing stuff. Yeah, like the math here is like very basic. Like it's just being run for every, pixel on the screen, but we're just doing like some stupid things like, well, yeah, so that actually will show where that issue starts showing up. So if we decrease this, then this like black hole in the middle loses like some. We can zoom in here, but this isn't, obviously we still need to fix this error. Of course, of course. So once I like implement like the fixed point thing, it's gonna result in like a little bit of a slowdown, but if I just do it correctly, it's gonna allow you to zoom in like much further, and it's only gonna be like a constant slowdown. It's never gonna like increase if you zoom in like too much. Oh yeah, of course. But the thing is you don't have to like, if you just use an integer for like this zoom value, um, and then just calculate like the deltas using like floats, it's never gonna get like you're gonna like increase the range like so much just by using an integer that it's like not even gonna be yeah, it's not even gonna like be comparable. So yeah, what do I want to do here? So the next step would be figure out like a fixed point thing. So um what we want is fixed point accuracy. So hmm, hmm. So to do this, we need to basically um think it involves like doing a part of this math a little bit differently, I think. I think it like could be based on like using the constant term or adding in the constant term, and that would be squared using an integer at the end. Um, I need to go to the washroom, so I'll be right back. Curious, but admire people who work on on places like Shader Toy. Shader Toy. Not sure what that is. Oh, I see. You can do this like on the web. That's cool. Yeah, some of this is pretty interesting. Um, what on earth? Yeah, well, of course, there's like a lot of yeah, that's cool. Of course, this can be drawn at like a much higher resolution, so but that's cool nonetheless. Um, Gator toy. This does remind me a little bit of like Uzumaki. Uzumaki. So, um, how can we do this one? So the iterations, the zoom. I don't think like lowering the iterate. I think lowering the iterations is like bad. Yeah, very bad. One high iteration. For now until we figure out the fixed point thing. Um, right. So these are going to be like becoming very small. Um, because Well, if the bounds are like this, though, that doesn't seem like that should be so small, right? Oh, yeah, no, sorry. These bounds are like tiny. Right. Yeah, these bounds are very, very small. Um, at some point, maybe. I'm not like that skilled yet, just yet, at building this OpenGL stuff. So this isn't like my first project in OpenGL, but you know, it's my first time doing like a bunch of math and crazy stuff in the shader, of course. um, I've used like textures before, but this is like doing some computation with the shader. So, um, but yeah, so basically, um, yeah, this fixed point value is like very very small already. So, um, and then so you take this, these is like the corners, and then you have to divide the corner by however many pixels are here, like 1,000. So it's even smaller than that. Like it's this is already like what's the so right now we've got like basically 0.00 uh 3 zeros and then like 9 and our dimensions. So by well yeah, roughly the same thing in both directions. And then if you divide that by like 1,000, so you add another 3 zeros, like that's very, very small for a float. Like it's not very, very small for a float, but it's very, very small for like a float delta. So um so in smooth vec 2p, well, that's gonna be interpolated, but and it's also not a uniform. It's like the default. The position is a vertex. What are the vertices? The vertices are always the same in this case. Um, so what about um yeah, so how do we do this? I don't know. I'm not actually sure. I might have to do the research because the as you just zoom in, it's gonna like start getting bad. So Hmm. 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 So we don't really need that, but so hmm. So how can we do this? Like maybe I just have to straight up just use fixed point and then um should maybe look up fixed point calculation. So how do you do this? So usually to do fixed point, you have to. I might review. I have to do some review here. Um, like if we scroll around, right? I mean, it can. So the thing about the values of this thing is that um we could use like very high, very high precision. So we could use like we only need like 3 or 4 bits for like 3 bits really for the non-fractional part, and then we can use like the other 29 bits for the fractional part, um, which gives like a very nice delta. But I need to figure out how to do the math. Um, so I see. So fixed, you just use like integers, and then when you go at the end to calculate the final result, you just have to shift. You just have to, yeah. So how do you convert? Um, hmm. But how do we do the fixed point math though? Um, no, I don't want to use double. Double is dumb. Um, yeah, I think I remember a post called "Fixed Point is all you need" or something. Um, huh. Yeah, this is gonna be difficult for me. So, So how do we do this then? Huh. So I will have to figure this out later, I think. And I'll probably come back and do this tomorrow. So I will probably, let's see, we've got one viewer. I think for now I will just call it quits for tonight. Um, I will upload some code here. Let's see what have we changed. So, well, I don't want to include all that, but um, let's scroll around a little bit, find some fun. Well, I shouldn't just. Don't know if I want to pause on a somewhere here. Maybe is better. Um, so there's a few things here that are not needed. So for example, if we do the build, I think normalize, so normalize is not needed, which means square root is not needed. Right? So we can get rid of this. And then oh, and magnitude is not needed either right now. Delete that. We are using sub. Okay, so that is good. So we have um, for now we will get rid of the DD this. I'll look up some better math for doing that later, I think. And then also what's going on here? So 2, 4, 5, 8. Okay, that's fine. And then um, that is not there anymore. I might still need that, so I'm gonna leave that code. But all of this code here just be commented out or deleted. This here, get rid of this for now. Delete these comments. That is not going to get committed, but the rest of this probably is good to go. Yes, so okay, let's make sure I didn't break anything. Not. So let us add -e main.c. Sign even getting used, no, is oops. Let us delete all this. So sine is not being used. Clamp is not being used. Between is being used. Well, in that assert, that's fine though. Absolute is being used, so so that is good. So okay, so this is good. This is all fine. Um don't want to commit any of this junk. That is fine. This actually might make this corrupt, but we'll see. Good. Okay. Cool. And then the shader stuff is minimal. Cool. Use velocity for scrolling or panning and do zoom on CPU. So that is pretty good to go for now. Cool. So thanks everyone who was watching. I will see you all next time. Bye.